Okay, good afternoon, or maybe good morning, depending if it's before lunch. Isn't this great that you get to hear my voice even when I'm not here? We're going to start today. You should have your notes paper out. It's the back of the notes paper that we did on Wednesday. You're going to need that paper to write some things down on. I just want to remind you before we start of what you did for your homework. You were given some functions like this. Ooh, it's not writing very well. Each time I gave you a factored form. Something like that, maybe. And your job in your homework was to do two things, basically. One was to come up with the solutions, which you would do by making mini equations, right? So those would be the solutions. And the other thing was to go through the process of superfoiling and get it into standard form. So we have looked at two ways to write a polynomial function. One is called the factored form. This is factored form, and factored form is really nice. You don't have to write this stuff down, by the way, just listen. Factored form is really nice because you can use it to find the roots very easily. And then we also have the standard form, which is nice because you want the standard form in order to figure out the y-intercept, right? That would be -6, and the end behavior. You're going to look at this to figure out the end behavior. Goes like that. Okay, so last time I started you with factored form, and I asked you to find standard form. The difference today is that we're going to start with the standard form and we're going to work towards the factored form. So we're going to be going in opposite order. Okay, so now you need your paper from last class. This is on the back, and it says factoring cubic polynomials. So I'm starting you now with a standard form equation. So our big question today is how do I factor cubic polynomials? And honestly, we're going to spend a few days working on this. Today we're just going to do two special types of factoring, and these you're actually for the most part already familiar with, and then we're going to learn some stuff in future classes that will be really interesting and exciting. Okay, so I think if you look at this function, you actually already know how to start factoring it. And I think that you would probably say, oh, the first way to factor anything is to do the GCF. And I would agree. So I'm going to go and factor out the GCF. Now, actually, I'm going to back up a little bit because I think the GCF here might be easier for you guys to see. The GCF is -2x. And what I've noticed a lot of people having trouble doing is figuring out, well, after I realize that that's the GCF, what do I put in the parentheses here? So one strategy that I've seen some people use is to write it like this and say, okay, what I'm really doing is I'm dividing each term by -2x in order to figure out what goes inside the parentheses. So if I do -2x cubed over -2x, that just leaves x squared behind. -10 over -2, that becomes plus 5x, and then plus 6. Okay, so once I have that GCF factored out, what's in the parentheses now, right? This is just a quadratic, and I know how to factor quadratics. Factors of 6 that add up to 5 are 2 and 3. And I can go right here, -2x, and I can factor that x plus 2, x plus 3. Now, I am able to take this shortcut. I just want to make a note. I took a little shortcut here. I didn't do a box. I didn't do grouping because the leading coefficient right here is a 1. If there's a leading coefficient there other than 1, then you have to do your grouping method or your box method. But with just a 1 there, I can go straight from this 2 and the 3 right to my factors. Okay? So here's my factored form, -2x, x plus 2, x plus 3. Okay. Next, we want to come up with the x-intercepts or the solutions or zeros or roots or whatever. And to do that, we're going to make mini equations. Now, because I have 1, 2, 3 factors, I need to write 3 mini equations. The first one might be a little bit of a surprise. I need to make this into a mini equation. -2x equals 0. x plus 2 equals 0. X plus 3 equals 0. We're used to solving these. But this is also a legitimate mini equation. Negative 2x equals 0. Divide both sides by negative 2, and you get x equals 0. So those are my solutions, and I'm going to write them in red maybe. 0, negative 2, and negative 3. And I think we talked about in class last time, one of the patterns is that if it's degree 3, you can have up to 3 different roots. 0, negative 2, and negative 3. Okay, I'm going to find my y-intercept, and I do that just by going back to my standard form up here and plugging in 0 for x. Well, if you plug in a 0 for every value of x, or every place that x appears, you're just going to get 0. So that's my end behavior, 0, 0. Or sorry, that's my y-intercept. And my end behavior, again, I'm going to go back to my standard form and look at that to make this decision. It goes like that. As x approaches negative infinity, I'm looking at this arrow here. It's going up, so f of x approaches infinity. As x approaches infinity, my eyes are on this arrow, my right hand going down in my dance move, and f of x approaches negative infinity. Okay. Now, I can take this information. This is just like last night's homework. I have some roots, I have a y-intercept, I have end behavior. I can put all of that together on, let's see, on here. Here's my roots, 0, negative 2, and negative 3. Oopsie, 0, negative 2, negative 2, negative 3. I might need to erase that. Let's do this. Okay, 0, negative 2, and negative 3. Those are my roots. My y-intercept is 0, 0, so it's also a y-intercept. It's an x-intercept and a y-intercept at the same time. And I know that my end behavior, from here, it's got to go up, and from here, it's got to go down. Now, what we still need to fill in, and last time we were just kind of drawing in a curve, right, in between here, just kind of connecting the dots. What we want to add today are a relative minimum and a relative maximum. So we want to actually know what those points are, right? I know that my graph, I'm going to draw it over here. I know that my graph is going to look something like this, right? It's going to go through these points, right? But I don't really know what this mountaintop is going to be. I call it the mountain and the valley. I don't know what those points are. You can use a graphing calculator, though, to help you find those points. All right, this point down here at the bottom, that's called the relative min. And up here we have the relative max, relative maximum. So we're going to use a calculator to find that. I'm going to open up my calculator. Hopefully it works now. And I'm going to show you very quickly how to do this on the calculator. You got to go to y equals and put in the equation. It doesn't matter if you decide to do it in standard form, or, oopsie, that's not what I wanted. View. Okay. It doesn't matter if you put it, okay, in standard form or in factored form. I'm just going to go to y equals and put it in standard form. And I got negative 2x. Okay, I just entered the equation into y equals. I didn't think you needed to watch me do all of that. I just took this equation, I typed it in here, and now I'm going to look at the graph. Okay, what I see is exactly what I expected. I see the end behavior that I thought I was going to have. I see that the roots are negative 3 and negative 2 and 0. But what I want to find is how high this goes right here, what the maximum point is and what the minimum point is. I'm calling them relative maximum minimum because the actual, what's called the absolute maximum is infinity, and the absolute minimum is negative infinity. So we call these relative, these ones that are in the middle. Now we have a tool on the calculator to do this, and we've used this before when we were doing like fence problems. You're going to go to second calc, and we're going to pick maximum. And remember that if you're doing this on the calculator, you have to put the cursor first on the left. Oopsie, I think I picked the wrong one. Second calc, number 4. There it is. Left bound, you have to tell the calculator. So if I want to know the maximum first, I'll do that one first. I'm putting it on the left side of the maximum. Push enter. Scroll over to put it on the right side of the maximum. Enter. Enter. And it's telling me that my maximum point is at negative 7.8, negative 0.78, and 4.23. So I'm going to write that down. That's the maximum. Negative 0.78, 4.23. Okay? So that means on my graph, I can actually put that point, negative 0.78. Oh, I need some little tick marks. Going up, 1, 2, 3, 4. I'm going to actually put a point here, the best I can. It's not going to be perfect, at 4.23, okay? And then I can do the same thing on a calculator to find the minimum. And I'll do second calc, and I'll select number 3, minimum. And again, I have to put the cursor first on the left side of that valley. Whoops, maybe that's a little too far. Left side of the valley, and then on the right side of the valley, push enter. Again, and it's negative 2.55 and negative 1.26. Negative 2.55, negative 1.26. Okay. So now I can go and put that point on the graph too, negative 2.55, negative 1.26. And all we're doing here is we're just adding more detail to this graph that we're drawing by putting in the relative maximum and the relative minimum, okay? So let me just get rid of that. This is the relative max. It's the top of the mountain on the graph. And that's the relative minimum. Okay, I'll label those. All right, now at the bottom we have another problem. So this is basically, I'm using the GCF to get to those 3 factors here, 2x, x plus 2, and x plus 3. At the bottom, we have another example where there is no GCF, right? I'm looking at this, I'm like, could it be x? No. Could it be 2? No. There's no GCF. Now, for people who already do factoring by grouping, this is going to be very natural for you. If you normally use the box method, it might feel a little bit weird at first, but we are going to try to factor this by grouping and see what happens. Okay, so this is my first group, and this is my second group. And if you remember, with factoring by grouping, you're looking at the first 2 terms only and asking, what is their GCF? So I can recognize that their GCF is x squared. Except there's something very wrong with the pen. X, wow. X, I'll try it here. X squared. One more try. The GCF of the first 2 is x squared. Okay. If you divide each of these terms by x squared, right, you get x plus 2. And then I look at the next 2 terms, and I'm like, well, negative 4x and negative 8, what do they have in common? They have negative 4 in common. And if you divide everything by negative 4, you get x plus 2. Now, people who do the grouping method know this is where the magic happens with the grouping. If these are exactly the same, then you can factor by grouping. So because I have that, that's what they have in common. That's my first factor. Wow, this is really crazy what's going on with this board. That's my first factor. And my second factor is going to be x squared minus 4. Now, normally if you're factoring by grouping, you're done at this point. Right? Except this second term here is quadratic. X squared minus 4 can be factored again. It's the difference of squares. So I'll factor that. I'll leave this one here. And I'll factor this one, x plus 2, x minus 2. And that's going to be my factored form, x plus 2, x plus 2, x minus 2. We can use each of these to make a little mini equation in our minds. This first factor, x plus 2, this would be the solution. Second factor, that's the solution. Third factor, That's the solution. Now we should be hopefully recognizing like, ooh, look, there's a double root, so we're going to get a bounce at -2 because of that double root. Go back to your equation, your standard form equation here at the top, plug in a 0 for x, and you get -8. So that's going to be my y-intercept, 0, -8. And again, I'll also look up at the top to figure out the end behaviors like this. Oh boy. The end behavior like that. So as x approaches -infinity, f of x approaches -infinity. As x approaches infinity, f of x approaches infinity. And I can use those three things, the roots, the y-intercept, and the end behavior, to make a pretty good graph. And I'll put the roots at -2 and 2, knowing that this one's going to bounce. I'll put my y-intercept down here, 1, 2, 3, 4, at -8. That. And then I'll kind of use my end behavior to connect the dots, more or less. So I know from here the graph has to go up, and from here the graph has to go down. I also know that it has to bounce right there. So really the only thing left to figure out is what's going to happen with this graph right here, right? How low is this going to get to the relative minimum? This is my relative minimum. Okay, and this is my relative maximum right here. My relative maximum, I don't need a calculator to know that that's just going to be -2, 0, right? That's the bounce off point on my graph. And the relative minimum, if you use your calculator to find the relative minimum, I think you'll find it's, I can't remember. It's 2/3 something. Let's see. And -9.4. I'm going off memory there. It might be -9.5. Use your calculator to figure out that relative minimum. Okay? Now, you're going to be working today to practice these a little bit. You're going to be working on your homework and on another assignment to practice these. Before you get into the practice, I just want to make sure, because I feel like the hardest part of this is the factoring by grouping if you're not used to it. So if you'll grab a piece of scratch paper off your desk, I just want you to practice one more problem with factoring by grouping. And you can work on it and then unpause it when you're done. Make sure you did it correctly. I just want you to factor by grouping this function, x cubed minus 3x squared minus 9x plus 27. Okay, so just see if you can take that equation down to, your goal is to get to 3 factors in the end. It's degree 3, so you're expecting to get to 3 factors, and you're going to do that one by grouping. So go ahead and pause it, and then when you're finished, turn back on and you can check your work. Okay, so I'm going to make 2 groups. In my first group, I'm looking at those 2 terms, and I think they both have an x squared, so that comes to the front. And what's left over, or I guess left behind after you factor out x squared, is x minus 3. And then over here, I'm looking and I see that these both have a 9 in common. I'm going to make it -9 because of this negative sign here. So I'll divide both by -9. And I'll get x minus 3. All right. Now this is the magic of the grouping method. If these are the same, we are good. You're going to bring that to the front. And the other factor is x squared minus 9. So I'll finish this by just bringing this x minus 3 down. And x squared minus 9 factors to x plus 3, x minus 3. All right, if you want to go one more step with this problem, you can write down what the roots are. The roots are 3, -3, and 3. Okay, so your notes are done. you can check in with a sub and get your next assignment so that you can practice these skills.